Yeah, I need to show this slide for you guys. Yeah, I would first give a brief introduction about EL. We refer to expression language as EL usually, and talk about the new syntaxes that we introduced in expression language 3.0. That include the operators, lambda expressions, and some collection supports. Then the second half of the talk would talk about the new APIs that we introduced. They include APIs for standalone environment and other stuff. Yeah, most of you probably know what EL is, but this is just a brief introduction. It's a scripting language for accessing and manipulating Java objects. Was first introduced in JSP standard tag library JSPL, and later on, it was included in JSP, JSR, and now it's been used by other technologies like CDIs and etc. Just to give you a simple example, like if you want to print out the value of a parameter, in a JSP page, you could write a Java scriptlet for it. You get the request object, you call the get parameter, passing the argument name, and then you print it out. On the other hand, if you use EL, you don't need to write Java scriptlet at all. You could just say, usually the $, parentheses, the curly brackets is the, delimiters for expression language in JSP. So you could just say param.name, and then, the expression language engine would, go and evaluate, that expression, which turned out to be the same as, calling get request, get parameter name. Yeah, you guys probably know all this already. So, what is new in EL 3.0? Okay, we introduced new operators. We have a string concatenation, assignment, and semicolon operators. We also introduced lambda expression. It is a very simple and powerful addition to EL, and we would use that extensively in the collection supports. Yeah. Then I would also, the EL 3.0 also introduced a new API for standalone environment and other stuff. Okay, about the new syntaxes. It's incredible, to think that, the current EL does not include a string concatenation operator, and a lot of users have been asking, for this particular operator. So we, added to the current EL, and the way to use it is just like, you use that in a Java program. So you could, string a number of EL constructs together with the plus operators. And so in this current case, we have, hello, and then we want to evaluate the expression user plus .name, and then we also want to concatenate that with, another string. So this is a new addition. Usually the EL expression, you need to include the curly bracket to it, but since it's understood in this talk, so I'm going to remove that restriction for now. So drop it like this, so it becomes clearer that what we are doing over here. The overloading rules for the concatenation operator is similar to Java. If you have two numeric value, then the plus is the addition. If one of them, is a string, then it is a concatenation. So nothing new about this one. Another new addition is the assignment operators. You could already do assignment right now in EL, with APIs. The ELResolver includes a method called setValues, but you just cannot do it in an expression itself. And this addition would fill the gap there. So you could assign an expression to a variable, to an ID, or you could assign a value to a field of a bean, or you could or that include assigning a value to a map. So these are the three examples that you could use the assignment operator. And the assignment operators also returns a value like in the Java language. And the rules is also similar to the Java, in that it is right associative. That means that you will evaluate the expression on the right hand side first, and then before you assign it to the value on the left. Just a technical note for those that are interested. The assignment operator is currently handled by whatever ELResolver that is used in the evaluation of the current EL context. And it is the ELResolver that determines whether assignment is allowed at all, or whether if the target of assignment does not exist, whether you allow creation of a new target. And so this is all under the control of ELResolver, and the behavior could be changed by the user by introducing a new ELResolver to it. The next operator is the semicolon operator. It also behaves like the semicolon in Java. So you could string a number of expressions together, with semicolon. The only difference, of course, is in EL, we only deal with expression, not statement. So so each of the EL expression, is string together, and the value of the semicolon operator is the last EL expression that you evaluate. So the other EL expression is just for side effect only. So in this example, the second one, you want to dump the value of a variable A, and then you return the value of A, as the return value for this expression. Yeah, that's what I just said. Okay, I want to get into more interesting topics, like lambda expression. As you all know, lambda expression, is going to be included in JDK 8. So, but we feel that we need it, right now. The current EL requires, the JDK 7, and of course, it's not in the JDK 7 yet. Yeah, but we have been working with the spec list of the lambda expression in JDK 8, and so we want to make sure that what we have here, would work with JDK 8 when it comes out. And one of the things that we try to do is to use the same syntax for lambda expression. So in this case, for those who don't know, a lambda expression in EL is much simpler than the one in JDK 8. And it is just like, a nominus function, in EL. It is a function without a name. And the syntax, we use, the same, arrow symbol to separate the separate the lambda parameters from the body of the lambda expression. The parenthesis for the lambda parameter is optional if there is only one parameter. So, like in the first example. So, in this case, in the first example, it is a lambda expression, and the expression body is x plus 1, and x is the parameter, for the function. And you also need to have a, lambda expression could also specify for 0 parameters. In the third example, it's just a constant expression 64. If you have 2 parameters, then you do need to also, separate those by commas. So the last example, specify a expression with 2 parameters. Yeah, so you have a EL lambda expression, and you could actually evaluate that expression immediately, as in the first example. So yeah, you supply, the syntax for the evaluation is the same as the function call. So you supply the argument 10, to this expression, and it got evaluated right away, and return a value of 11. The second example shows, a evaluation with 2 parameters. Yeah, you can also assign, the lambda expression to an identifier, and by doing so, you actually give, a name to the function, and you could call the function after it has been assigned. And so the first example, is identical to the example we have showed you before, except that now, you could call this function more than one time after it's assigned. So yeah, so the function could either take one parameter, 2 parameter, or whatever. Yeah, this is a more interesting example in that the lambda expression could be recursive. So once you assign a lambda expression to a identifier, then it could be invoked inside the body itself. So we could use this to implement factorial function, and we could also evaluate it right away. Yeah, but it's more common to actually not to use the lambda expression inside EL itself, but to pass it to a method in Java and have that invoked. Okay, so in the current specification, we also introduce a new class that would capture the runtime instance of a lambda expression. And so if you pass it to a Java method, then what you get is a instance of Java XEL lambda expression. And I would cover the API later, but just let you know that once a Java object and a Java method got a instance of this object, then it could call sort of evaluate the lambda expression by calling the invoke method on it. Yeah, so we use this to implement some of the collection operations that we are supporting in EL 3.0. Yes, just a technical note here, that for those who are interested, the lambda, we already have the value of, the value expression in EL, and right now a value expression, is, you could look at it, as a path tree for a value for a EL expression, and so it's really easy to implement Lambda expression with the current EL. We just need to add parameter to a value expression, and make sure that those parameters can be accessed in the Lambda body itself. And we are currently working with JDK8 guys to make sure that the EL Lambda expression could be used to call methods in a Java method that expects Java Lambda expression. And that part, of course, is still under work because the JDK8 is not out yet. But we expect that we are going to do to be able to do that when it comes out. Okay, next I'm going to talk about what kind of support we are going to have in EL 3.0 for collections. And I know in the description there we said that we are going to support the LINQ operators, but that is actually still under review, and with the current developments in the Lambda expressions in JDK8, and also with the work they are doing on supporting collections, we might change what we have in EL to be more alignment with them. And of course, the goal here is to present only one view of what we are going to do, either from EL or from JDK8. And also, later on, if JDK8 is released, we could call their methods directly instead of doing all this in EL. So that part is still under design right now, and it might. Yeah, I know the current EL says that it was supported, but it might change. Just a warning. Okay, about the collection supports, we do introduce new syntaxes for constructing lists, sets, and maps. So the syntax is also very similar to the one that is going to be used in JDK8. But of course, in EL, being a dynamic scripting language, we also allow any expressions inside the literal, not just the literals. So just give you an example. If you want to construct a set, then you just need to use the curly bracket for it. So yeah, so in EL, everything is an object. So the set, does not have to be of the same type. Okay, the second example shows. We also have a similar construct for list, and we use a square bracket for it. So the second example shows that you could include a list inside a list. Yeah, so you could construct multiple levels of lists this way. And of course, you could also include things like evaluating a real expression like a plus b or something. Yeah, map is also similar. We use the semicolon to separate the key from the value. So you could construct a map, with key, and then of course any expression could be used for the key as well as for the value. Yeah. So so the syntax is very familiar. I think there are other scripting languages that use other syntaxes, but this is the one that's going to be used by JDK, and people familiar with JSON will also recognize this right away. Yeah, so I just mentioned that we are going to work with JTK8 to make sure that the collection operations works together well. Yeah, this is also just a technical note, to say that the most of the operations that I'm going to describe here, they are implemented with ELResolver currently. And like I say, when JTK8 comes out, we might change the implementation to call the JTK8 method directly. But currently, it's supported this way in JTK7. Yeah, so there are two kinds of operations in the collection operation. If you have gone to the talk, the Brian did yesterday, then you would realize that we also have similar operations over here. Most of the operations, they are lazy in a sense that you would only iterate over the members of the collection only when it's necessary, and so we avoid creation of intermediate collection, and we also avoid doing work too early when it's not necessary. But there are some operations that are eager in the sense that we need to iterate over the entire collection. And so an example for the first kind of operation is filter or map. In the filtering stuff, we only do a filter when someone asks for a member of the collection. And for eager operation, the ForEach operator is an example of this, in that we actually iterate over all the collection members, to get to it. And most of the collections, actually works on streams of objects. Okay, so you could imagine, if you have a collection of objects and you want to get those objects one by one, and it comes in a stream. Okay, and there are two types of streams here. One is the stream with a single value, like a list. And also, you could have a stream with two values, like a map. In that, you will get the key and the value in the stream, at the same time. And unlike the JTK streams, in EL, all the streams are finite, in a sense that you know the size of the stream, before you do the operation. Okay, but JTK8 also support infinite streams in that you could get a stream from, say, reading a file or connecting to the web or something. We currently do not support infinite streams yet. Okay, so I'm not going to cover all the operators that is going to be supported. So I will just cover some of them to give you a flavor about what might be in there. And like I say, this is still not cast in concrete, so it might change. The first operator is ForEach. So you have a list, then you want to call the ForEach method, and in there you pass a Lambda expression. Okay, so what this the way to read this is for each of the elements in the list, you evaluate the Lambda expression, and the evaluation causes a side effect, which is to print out the value of the elements in the list. Okay, so like I say, this is an eager operation. So once this operator is done, you have already gone through an entire iteration for the whole list. Filter is the one that is lazy, in the sense that you don't you do not go through the whole collection, but you only do that when someone asks you to. Okay, but in this example, it shows that you have a collection, you have a list of products, and you want to apply a filter to it, and the filter says that the price, for a entry in the product, is greater than 10. Okay, this by itself, does not do anything. Like I say, because it's not evaluated when you have this expression. Yeah, map. Map is the use of the term is unfortunate because it coincides with the Java map. But map, you could also think of it as a transformation or a So what map is you want to take a element of the collection and apply a transformation to it and return a new value. So in this case, we are not interested in the product instance itself, but we want to get the name of the product. So this Lambda expression would do that, and you could also string a number of operations together. So in this case, we want to find the names of a product, whose price is greater than 10. So in this case, you apply the filter to it first to only get the product, with the correct price, and then you apply the map function to it to get the name. And map and filters are both lazy because they don't do anything. But we could also change the result of these two evaluations into an empty list. And in this case, the into operator would actually, the way to read this is to you want to put something into the list, and to do that, you call the map function to do that. The map function would try to get a product and evaluate the expression, which is the name. But to get an element of the product, then you will call the filter operation to call the filter method to it, and the filter method actually try to get a product by applying this function to see if it satisfies the function. If it does not satisfy the function, then you will try to evaluate the product for the next element until you get one. And once it gets a product with price greater than 10, then you will send it to map, and map will do the will do the transformation and send it to the into operator. So it works out well if you chain all these things together. Chaining the operation together is also common, in the collection support. You could chain those together to achieve, complicated operations. This is just an example of ForEach. So, this particular example could also be written using ForEach instead of into. In that, but you need to create an empty list first, and then in the for each loop, you actually add. You actually add the element to the list. So this and this, they are very equivalent. Sometimes you would like to flatten out a list of lists, and the FlatMap operation that you do that. I'm not going to go over the syntax. It's just that something you can do. The syntax may change also because it's a little bit too complicated at this time. So we might shorten it to this, if it's just a list of lists, but the first example actually is more general than the second. Okay. We also include operations like sorting to it, and like JDK 8 right now, the sorted operation actually takes a comparator for sorting. So you could specify a comparator to sort the thing that you want to sort. And in this example, the Lambda expression actually replaced the compare to method in the comparator, and the compare to method specify that if we want to compare two objects, it would return 0 if they compare equal, and it would return plus, if it would return plus, if it is the first one is greater than the second one, and it would be negative if the first one is less than the second one. So, but if the P and Q they are integers for double whatever, then you could implement this by doing the subtraction of the first one to the second one. So but of course asking the EL user to write a comparator is relatively, well, it's not difficult, but it is a nuisance. So we might come up with functions like this, like if you want to compare the prices, then the comparing is actually going to be implemented as a EL function, and the function will return a comparator, and they compare on whatever the map function specifies. So in this case, we specify that we want to compare the price only, and then we call the comparing function that returns a comparator, and that in turn fit into the Lambda parameter for the sorted method. If you want to sort the list in descending order, then what you need to do is just reverse P and Q, and of course we will also have function for it just to make it easier for the user to use. The sorting could get more complicated if you want to sort not only on the first key, but also you have a second key to sort. And of course, you could still do it, with comparators. Say, if you want to sort on the price first, then, if the price are equal, you want to sort on some other values. And so, you could write a comparators, this way. But, we might also include function to help the user to write this, in a way that is, more readable. So in this case, we want to, we have a composition of two comparators, and the first one, is comparing on the price first, and the second one comparing on the date. So these are just examples about what you can do with Lambda expression in EL, and obviously the user could specify their own comparisons, by writing appropriate Lambda expressions. Reduce is also another expression, another operation that we might support, and these operators go over the whole collection and apply a binary operator to it, and the binary operators would so the reduce, so this Lambda expression to the reduce, there are two arguments. The first argument specifies a accumulator. The second one, is specify the elements of the collection. So in this case, we want to apply the max function to the accumulator and the price, and the result of that of that evaluation would assign to the accumulator. So as you go over the collection, then you would accumulate the maximum of the expressions when you evaluate, and after you are done with reduce, then it returns the maximum. And of course, you could also use instead of finding the maximum, you could also do addition, which will give you the sum, or you could do minimum, which give you the minimum, and all of that. So still reduce is also a very powerful a collection operation. And yeah, so I'm not going to go over the map streams in detail, but we also have filters that filters either the key or the value of an element from the map stream. You could also do transformations on the values. You could also invoke ForEach on the map stream. Yeah, so just to give you another example of what you can do with EL, and this is actually used in current production. Say you have a number of computers in a cluster, and you have been collecting data on each of the computers frequently, say every second. Okay, so for each of the computers, you have all the matrices, and that is a list. And you want for each of the computers, you want to actually find you want to include all the data you collected since the beginning of the day, and of all those data, you are interested in looking at the CPU usage. And so the average of the CPU usage greater than 80, is that, okay, I want to look at all the CPU usage, and and take the average, since the beginning of the day, and find any, is a method, that applies to a collection, and it will return true if any of the elements in the collector satisfy the condition, and the condition here is you want the average is greater than 10 and greater than 80. Yeah. So in this case, instead of writing a very complicated Java program, you could use EL to evaluate all this. And yes, just to make it a little bit more complicated, the similar example, in that instead of finding out whether any of those computers have the CPU usage greater than 80%, you want to print out all the names of the computers that satisfy this criteria, and so this expression could let you do that. Okay, so yeah, I'm done with collection support description. I'm going to go over some other new syntaxes that have been introduced in expression language 3.0, and one of the often requested feature is that, okay, I want to reference a static member. How do I do that? And in EL 3.0, we introduced new syntax for doing that. And so you could refer to a syntax using the syntax that is familiar with everybody in Java, and then you could say boolean.true. So you could actually refer that directly. You could also refer to a method and call it, and this method is also a static member. And we introduce a new syntax for referring to a class in a package. We do that because we don't want to confuse users with the dot operator that is already working, for accessing the fields. So, the class reference, is capital T with the actual Java class. And yeah, we also place some restrictions on, when you could use, such reference. We would like, so the class needs to be imported before it could be used, because otherwise, there may be some security issues. Okay, so I'm going to talk about, the APIs next, and yeah, I'm not also going to cover, everything in there, but I also want to present to you some of the more important ones. And one of the complaints that have been, the one complaint that the current user have, is the EL engine is just too difficult to use. So before you could evaluate your expression, if you're not doing it in JSP or JSF, you want to use it in a standalone environment, then you have to construct, a lot of background objects before you could use it. Things like ELResolver, ELContext, and that. So, but in a lot of users, they just want to evaluate an expression right away. So we introduce new APIs for doing so. And how easy is it going to be like, to evaluate expression? It's real easy right now. We have a new class called ELProcessor, and in there, once you get an instance of ELProcessor, then you could call the EL method directly to evaluate an EL expression, like the example over here. And there are a lot of hidden things that is done behind the back, and of course, the new ELProcessor would contain a default EL context, and with it, we also introduce. We would have put together a number of ELResolver that the user might use. So everything is done by default here. And yeah, if you got an ELProcessor instance, then of course, you could define a bean, to tell the EL engine what certain top level EL identifier mean. And in this case, we would like to define a bean called cells. We get it from the database. Then once the cells is defined, then you could use it in the EL expression right away. And we also allow users to define functions locally. So you could specify a function. And the EL function, take a namespace. So the first two arguments is the namespace of the function and the name of the function. Then you specify the package the function is in, and also the method in the package. So there are 4 arguments here. There is also another version of define function that takes a method object, but I am not showing it over here. So once it's defined, then you could also use it in a EL expression. So this would let the user define a function on the fly, quickly. Then similarly, you could define a variable, an instance of variable mapper, and in this case, recall a EL variable takes an EL expression, not a Java object. So the definition of an expression, so the definition of the top, takes the EL expression. And of course, right now we include lambda expression in EL, so you could actually define a lambda expression as a EL variable. And you could use it in the EL expression. Yeah, so EL processor is the thing that the user would use mostly. We have another level of API support called EL Manager that actually does most of the support for the user, and it includes some of the less often used functions, like you want to add an ELResolver to it. So you want to add an ELResolver, then you get to an EL Manager and call the add ELResolver. And EL Manager also takes care of importing a EL class. Yeah, so in addition to the support for standalone environment, we also have other new APIs that have been there are a lot of requests for it. And one of the things that we add is to add an evaluation listener to the engine. And what it does is it allows the user to supply callback function for before and after the EL evaluation. And also a lot of users would like to know how a property is resolved by ELResolver. So we also include a callback function for property resolution. Once a property is resolved, then whatever EL user specify in the listener would also be called. So yeah, so this is one of the examples of how you could add a evaluation listener to the evaluation engine. So in this particular example, the user want to print out the expression before it is being evaluated. So what he does is he supply a evaluation listener. In there, he override the before evaluation method. Yeah, the other thing we added, to the ELResolver is to allow the user to specify a custom type conversion. So it's, so one of the things that the EL have been asked is, we have been doing a lot of type conversion when we evaluate an expression, and also when we assign to a value. And in some time, the default rule is not what the EL user want. And so right now, then the EL user could actually add an ELResolver that handle his own conversion. And we added a new method called convert to type. And in there, the user could specify how he wants the thing to be converted. Yeah, so this is also an example to show you how you could add a custom type converter to the system. So in this converter type here, you specify a special conversion if the target type is what you're looking for. Okay, so in this case, if you have a string and you want to convert it to my bean, then you just call the so you just call a constructor to do that, and the EL engine would actually invoke this method on any conversion, and if the type matches, then it would apply this particular conversion. There are some new APIs for support of Lambda expression. Yeah, so like I say, there's only one method in the Lambda expression itself, which is to invoke it. And to invoke the Lambda expression, then you pass the EL contact with a bunch of arguments. And in EL context, you also need to. We also added, free method to support the evaluation of EL argument. One of them, one of them is called before you evaluate a lambda expression, in that you import the parameter into the evaluation context. And the other is if you are done with the evaluation, then you would want to get rid of those parameters on the stack. And the first method is to get to the arguments of the lambda expression itself. So yeah, but most of the users probably would not have to deal with this. It's just new API that we added for support of the lambda expressions. And this is the end of my talk. Right now, the specification is at a public draft. So anyone is interested could go to the JCP site and download the specs and the Java docs. Okay, so it's there. The review period is over, but still, if there are comments or questions, you could always send email to either to me directly or to the Java.NET project. And we keep a project over there. And in the Java .NET project, it's an open source project, and anyone could download it and build it and run it. But right now, like I say, for the collection support, we still have the LINQ operator over there, and it's all working, but that might change. So, just if you want to play with the collection support, then just be aware that it's going to be changed. Questions? Well, great. No questions. But if you run into anything, or any comment or anything, by going to the JSPC site or the open source project, let me know. It currently is still not final, so it's still not too late to add things and change things. Thank you.